Alright, so I want to make sure that we are doing this last little problem correctly. So we have two buggies separated by 2 meters, and they're going to collide, and we want to write down the equations of the motion for each buggy. So that's that y equals mx plus b equation for each one. So we have, for the first buggy starting, so this is kind of the situation. I'm going to have one, whoops, it's a little crooked. So, you know what, I'll draw it here. So we're going to have one buggy starting here and another here. And buggy 1 and buggy 2 are like that. And so let's be clear here. We're at the 0 meter mark here for buggy 1 and the 2 meter mark for buggy 2. So for buggy 1, we've got an equation 0.4t plus 0 because we start at 0. And for buggy 2, we are going backwards at 0.6 meters per second times t plus our y-intercept, which is that we start at 2 over here. So now let's determine the position and time the cars will collide. So they're going to collide when they have the same position. So that'll be 0.4t plus 0 equals negative 0.6t plus 2. So we're going to end up actually getting that 1t equals 2, so they actually collide at 1 second. Now let's figure out where that's going to happen. We can plug into either formula here, so we're going to end up getting that with this in mind, we're going to actually end up, oh, actually, no, t is going to be 2 seconds. That's when they collide. Sorry about that. I did the math wrong. So now let's actually calculate when that's going to happen. So we're going to have x1 is 0.4 times, I'll put in 2 seconds. So they actually collide at 0.8 meters. Now let's go ahead and see if we can actually figure out when and how they meet. So I'm just going to give a little bit of time here, so we'll just say this is a lot of space to do this graph, but I'll do like, let's see if we can go all the way. Let's do this by 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll add one more little here, so this will be 10. So we're at so we'll do centimeters, but we'll do meters. So 0.2 meters, 0.4 meters, right? 0.6 meters, 0.8 meters, 1 meter, 1.2 meters, 1.4 meters, 1.6 meters, 1.8 meters, and 2 meters right here. And then let's see, so we'll do 1 second, 2 seconds, 3 seconds, and 4 seconds here. That's a lot of time, but that's okay. So 1, 2, 3, 4. Now let's actually plot this position as a function of time. So every 1 second, the car is going up 0.4 for the forward-moving car, like that. All right. So there we go. So that's the first car, and we plot its position like this. And then for the other car going backwards, that's negative 0.6 plus 2. So we start off at the 2 meter mark, and then after 1 second, we're going to go down 0.6. So 1, 2, 3 will be at 1 second, will be at 0.6. We'll move down 0.6 like that. So let's go down 0.6 more. And just to be absolutely safe, actually after 1 second, let's just be clear. So I go 0.2, 0.4, 0.6, and after 1 second, I'm going to end up down 0.6 from 2 meters, I go to 1.4. And then I need to go down 0.6 meters more in the next second, so 0.2, 0.4, 0.6, and I'll wind up here. And then after 3 seconds, 0.2, 0.4, 0.6 after 3 seconds. So it looks like my second car, I actually plot it like this, and when we actually look, they actually do meet at 2 seconds and 0.8 meters, which confirms what we got by doing the algebra. So that pretty much finishes up our practice exam, and I'll have this posted on Haiku, and when I see you all in 2 days, I will actually have another practice exam for you to study from as well.